Hello, my name is Stephen Kingsmore, and I'm the President and CEO of the Rady Pediatric Genomics and Systems Medicine Institute in San Diego, California. For the next couple of minutes, I'm going to tell you about my talk, which is titled Genome Sequencing, Precision Medicine in the NICU. By way of a backdrop, genetic diseases are very common, as you know, in level 3 and level 4 NICUs. They are the leading cause of death in NICUs, PICUs, and in fact in infants in general. And making a diagnosis in a timely manner in a NICU setting is a bit of a nightmare, as depicted here by an iceberg. And that's because there are in all about 8,000 genetic diseases, of which we know the molecular cause, that's the gene defect, for about 4,500. For the rest, we don't yet know that. But then to make a diagnosis more complicated in a NICU setting is just the fact that we're dealing with babies whose organ systems have not fully developed, and therefore the presentation may not be what's in the literature as the classic presentation. So to cut a long story short and summarize the information on this slide, this is a tough thing and we need better solutions. In response to that, over the last 4 years, my team has developed rapid methods of decoding the entire human genome, specifically in order to make a diagnosis in a NICU environment. And most recently, as shown in the bottom right, we published a paper saying that we could decode the genome for babies in NICU environments in 26 hours. And this has made a lot of headlines and is something very exciting, very new, and has broad potential to change care plans in NICUs across the nation. Just in a couple of slides to give you an appetizer for my talk, I'll just tell you about the results of the first 35 babies who went through this program. And this has been published, as shown on the left-hand side of the slide. So we enrolled 35 babies from a level 4 NICU at Children's Mercy Hospital in Kansas City and performed whole genome sequencing on mom, dad, and baby. 57% of those babies received a diagnosis by genome sequencing. So they had a genetic disease, we made the diagnosis. If we contrast that with what's the standard of care, which is all other genetic tests, they only gave a diagnosis in 9%. So certainly it looks like this works for NICU children or babies. If we look at the world's literature, which is shown on the bottom of this slide, the findings that we have in the NICU in terms of the usefulness of WGS, that's whole genome sequencing, or WES, which is whole exome sequencing, of 57% diagnosis rate, tallies well with what other investigators are finding in older children in terms of genetic diseases, and NDD means neurodevelopmental disabilities. Second key question to be asked is, does this make a difference in terms of the management of patients? And so we looked in the same 35 babies, and we found that in 65%, a diagnosis had acute clinical utility. In 20%, that was a strongly favorable impact on outcome. And the types of changes are listed on the slide. In conclusion, and in terms of the remaining questions, rapid WGS does appear to be effective based on small numbers for genetic disease diagnosis in level 4 NICUs. But additional questions still need to be answered in terms of the breadth of that utility. Secondly, timely diagnosis of genetic diseases, in other words, using a rapid protocol as opposed to taking a month or two, actually changes NICU management. And again, there are additional questions to be asked, such as how does it change management and what are the new work plans, care plans that it invokes. And so I think this is critical new information because I believe this will be the future of neonatology. And Francis Collins seems to agree with me, and so does President Obama, based on his State of the Union address. And so I think for us as neonatologists, this is an area that we need to start to learn about and start to gain some experience in. Thank you very much.